Hello, this is Mr. Craig, and with this video I want to talk about naming compounds or nomenclature with polyatomics. If you want to go to the same worksheet that I'm going to show the examples from, I would highly recommend that you go to www.avon-chemistry.com and come down here to the link that says General Chemistry or Honors Chemistry. Click on that. Then click on First Semester. Then scroll down until you see Nomenclature, or writing chemical formulas and nomenclature. Then click on Nomenclature. And again, you'll see this screen here. And what we're going to look at is naming compounds part 3, polyatomic. And again, I apologize for all the extra letters there. For whatever reason, the HTML went crazy. So I'm going to click on part 3, or the third one down. And you should see the worksheet that looks like this. Okay, so polyatomic ion compound homework. And I'm going to go back to the Elmo. Okay. All right. Now, looking at polyatomic ions, when you're doing polyatomic ions, probably the most important thing is knowing what the polyatomic ions are. And let's go ahead and write those down real quickly here. So looking at the polyatomics, what you need to do is you need to know the name and the formula for the polyatomic. And there's 10 of them. And I may not put them in correct order here, so I apologize. The first one is acetate, C2H3O2, and that has a -1 charge. And it'd be nice if I actually had it on the screen for you. So let's go ahead and move that over. So C2H3O2, that's acetate, okay? Or that acetate. Okay, so you need to know the name and the formula and the charge as well. Let's go ahead and make that a little bit smaller there. Okay, the next one, and again, I may not be going in order here, is nitrate, which is NO3 with a -1 charge. So nitrate, there's hydroxide, OH with a -1. And when we talk about acids and bases, we're going to talk about hydroxide a lot. So hydroxide. And also as a side note, this is our only polyatomic that ends in IDE. Okay? And that's one thing, that when we start writing chemical formulas or chemical compounds, that IDE ending is very, very typical of a non-metal with a element that ends in IDE. So that's our only polyatomic that ends in IDE, which sometimes can get a little confusing. That's why you want to know hydroxide. All the others are going to end in ATE for the most part. There's one other exception to that. The next one we can say is chlorate, ClO3 with a -1 charge, and that's ClO3. That's not an I. We don't ever have carbon and iodine, so that's whenever you see something like that, that's chlorine. So chlorate, let's see, what's another one here? I know there's another -3 or -1 one. Nitrate, chlorate, iodate is another one. Okay, so iodate. And I believe that's all the -1 polyatomics. All right, so the -2s, and if I forgot one, it'll come back to me. The next one is carbonate, CO3 with a -2 charge, carbonate. There's chromate with a -2 charge. And there is sulfate, SO4 with a -2 charge. And so far we've got, let's see, 5, 6, 7, 8. So I need 2 more. So my -3 representative is phosphate. And then my last one, and it's my only metal, because all these other polyatomics had negative charges, so those are represented as nonmetals. However, the last one is ammonium, NH4 with a +1 charge. Okay, so ammonium. So there's your 10 polyatomics, and if you need to see them, play back the tape or play back the video here. So those are your 10 polyatomics that you should have memorized and have the charges also memorized. So you need to know not only the name, the formula, but also the charge, since these are all components of ionic compounds. Okay. The nice thing about writing polyatomic ions or ionic compounds that are polyatomics, we still follow the same rules for naming ionic compounds. So nothing has changed there. So let's go ahead and start off. Actually, move that over a little bit. So in the last example, we had ionic compounds, and we went ahead and found out what the charge was, and we wanted to balance that out charge-wise. We're going to do the same thing here. We want to make sure that the algebraic sum always equals 0. So I'm going to do the same thing there. All right, so looking at this, let's get our periodic table out again. So we have calcium nitrate. All right, so we find calcium on our periodic table. Okay, and again, calcium has a -2 charge, or I'm sorry, a +2 charge because it's in group 2A. So we want to write the charge above calcium. That's +2. And then the nitrate is one of our 10 polyatomics. And the nice thing is there's only 10 that we care about. However, the reality is there's a lot more polyatomics, but these are the only 10 that we care about. In nitrate, NO3 with a -1 charge. Okay, so NO3, that has a -1 charge, so we'll write the -1, because we want to balance the charges out first. We have to balance charges out first. So the same thing that we did in the last one with the just naming ionic compounds, whatever the charge is, that's how many we're going to have. Whatever the charge is, that's how many we're going to have. So calcium will have a parentheses 1 and the nitrate 2. Now that we've got the charges balanced out, let's go ahead and write out our representatives. So calcium is Ca, and that has a +2 charge, and nitrate is NO3, and it has a -1 charge. Now, whenever you need to represent more than one of a polyatomic, this is the only time we ever get to use parentheses within the formula, is when we need to represent more than one polyatomic. Parentheses is never used for an element. It's only used for polyatomics. So since my balancing the formula requires 2 of those, I can't just put a 2 on the end of this. That just looks silly. Okay? I can't just write a 2 there, because somebody might look at that and go, NO32? No. So if I need to show 2 nitrates, I use parentheses. So parentheses, polyatomics. Probably the best way you can remember that. So if you need to show or represent more than one polyatomic, you better have parentheses around that. If you only need to show one polyatomic, no parentheses. If you need to show, say, like 2 calciums, you put a subscript 2 there. Do not put parentheses around an individual element. Just because it has 2 letters doesn't mean it's a polyatomic. All right, let's look at the next one. Potassium phosphate. So potassium, looking at your periodic table, okay. Potassium, group 1A, so it has a +1 charge, so write the charge above it. And then phosphate is a polyatomic. Okay. Phosphate has a -3 charge, so we're going to write -3 on there. So phosphate has a -3 charge, and we want that all to equal 0. So what that means is I'm going to need 3 potassiums and 1 phosphate. Okay, so make sure your algebraic sum equals 0 there. So let's kind of go the other way there. Okay, we'll scoot that over. Okay, so over here, my potassium, since I have a 3 there, I need to write K, which is my potassium, the 3. I'm going to write a subscript, just like I did when I was balancing the other ionic compounds. Okay, phosphate was PO4 with a -3 charge, so I'm going to write PO4. Okay, And if you need to, you can write charges above this, just to kind of keep yourself in check. So that's got a -3, potassium has a +1, I need 3 of those. Hey, that equals 0. Everything's great. And again, whatever's in my parentheses for my algebra only, whatever's in my parentheses, that's how many I have. So that's a 3 down there. Sorry, that kind of looks sloppy. Okay, so K3PO4 is potassium phosphate. All right, aluminum acetate. Aluminum, again, has the symbol Al. And since it's in group 3A, it'll have a +3 charge. So let's write +3 over that. And acetate is, again, if it ends in ATE, that tells you that you're looking at a polyatomic. So the acetate, again, the C2, scoot it over a little bit more. So the C2H3O2 is an acetate. So it has a -1 charge. So that means I'm going to need 3 of those, algebraically speaking, to get 0. So when I write this out, aluminum is Al. And then acetate is C2H3O2. That's one of the harder polyatomics to remember. And since it needs 3, I'm going to put that whole thing in parentheses and then write a 3 on the outside. Aluminum acetate. Now again, the 3 is because each one of these has a -1 charge and the aluminum has a +3 charge. And again, what I like doing, especially starting out, is putting the charges above it just so I can know. Okay, that's an option if you wish to do that or not. Okay. All right, the next example, number 4, ammonium sulfate. Well, again, that's one reason why you want to know your polyatomics. Ammonium is our only metallic polyatomic because it has a plus charge. So since I know it has a +1 charge, I'm going to write +1 above it. Sulfate, ooh, this is cool. We have 2 polyatomics. Sulfate is my -2 charged polyatomic. So sulfate, SO4 with a -2 charge. So I'm going to write -2 there. And so that means I need 2 ammoniums and just 1 sulfate. Okay. So I'm going to bring that over here. Make sure I still have room. So the ammonium is NH4. Now again, since it's a polyatomic and I need to show more than 1, I put that in parentheses. And then the sulfate is SO4. But since I only need 1 of those, no parentheses is put around the sulfate. Don't just put a set of parentheses around the sulfate because it feels good. The only time we put parentheses around a polyatomic is when we need to show more than 1. Because again, later on when we do chemical formulas for moles, we're going to need to be able to multiply and know how many actual elements we have within this. Don't worry about that right now. I just want you to be able to write these out. All right, looking at number 5, magnesium hydroxide. Well, find magnesium on your periodic table. So again, magnesium +2 in group 2A. So magnesium has a +2 charge. Hydroxide is that mean polyatomic that ends in IDE. Okay, so it's the OH. Okay, hydroxide. It's our only polyatomic that ends in IDE. And sometimes we might get confused and think, oh yeah, it's going to be one of these nonmetals in the nonmetal triangle. But here's the way to remember that. Hydrogen does not appear over here. Okay, only these things are our nonmetals that we drop the last syllable or last 2 syllables and add IDE. You never do that to hydrogen, ever. So these are the only things that we drop the last syllable or last 2 syllables and add IDE. Hydroxide doesn't fit the bill for our nonmetal triangle because it is a polyatomic. So since it's a polyatomic, okay, it gets the right to have that goofy name. All right. So hydroxide has a -1 charge. So algebraically speaking, we need 2 of those, and we only need 1 magnesium. So when we write out this formula, magnesium hydroxide, and this is where a lot of students get into trouble because they think to themselves, well, since there's no subscript on this polyatomic, if I just write a 2 here, I'm going to be good to go. Well, there's a difference between OH2 and parentheses OH with a 2 on the outside. Because here that tells us I have 2 hydrogens, but only 1 oxygen. But putting the parentheses around it Now it tells everybody, aha, I've got 2 of these. Whatever I have inside, it's just like a math function. So if I have 2 of those, then I focus on 2 of these in there. Okay? All right. Let's look at the next one. Perchlorate. I'm not sure if you guys have talked about the PERs yet, and I'm looking to see if I see any more. I'm actually going to skip the perchlorate because I don't know if you guys have talked about the PERs and the hypos and the ites. If you have, I'll make another video on that. So I'm going to skip number 6, and we're only going to focus on these 10 polyatomics. So I apologize for those extras on there. Let's go to number 7, the magnesium carbonate. Okay, so again, magnesium +2 charge, so magnesium has a +2. And then carbonate, carbonate is our CO3 with a -2 charge, so carbonate has a -2 charge on it. So we'll put a -2 on there. And since they're both either +2 or -2, we only need one of those. So magnesium carbonate is just MgCO3, no parentheses anywhere, because we don't need to show more than one polyatomic, so the carbonate's good to go. All right, the next one, lithium hydroxide. Lithium, again, has a +1 charge because it's in group 1A, so +1. Hydroxide, again, is our -1 charged hydroxide or polyatomic there. So it has a -1, which makes it very nice, because that means we only need one of those and one of those. So here we have LiOH. You're done. Don't do any more to that. No parentheses. It's a +1, -1, so it's written. It's beautiful as written. All right, magnesium sulfate. Magnesium has a +2 charge. Sulfate, again, is our SO2. Or I'm sorry, SO4 with a -2 charge, so it has a -2 value. Man, you guys are getting lucky on these. So magnesium is Mg, and the sulfate SO4 balanced as written. Skip number 10 because we're not doing bicarbonates. Skip number 11. Go right to number 12. Okay, number 12. Try that one on your own. Pause the video. Give it a shot here. All right, you've had a chance to try it. So ammonium, again, is our only metallic polyatomic, which is NH4 with a +1 charge, so +1. And nitrate is our NO3 with a -1, so it has a -1 charge, so that equals 0. All right, so we've got ammonium, NH4, NO3. Do not put any parentheses anywhere on that formula. Okay. All right. Now let's take a look at the next one. Okay. This is going from the formula to the name, and actually let me blow it up. Going from the formula to the name. Ca, and again, these are all balanced as written, so we don't have to worry about it. And if we come across any goofy things, we'll go ahead and discuss it. All right, calcium, and then carbonate. And the nice thing is, when you have ionic compounds, you name it, everybody knows what the charge is, so you don't have to do anything weird to it. So it's just calcium carbonate. Aluminum hydroxide. Again, don't worry about that 3. The 3 is because the aluminum has a +3 charge, while the hydroxide has a -1 charge. So aluminum hydroxide. Now this is the fun one, number 3. Number 3, here's how you solve for these types of problems. What you want to do first and foremost is identify the metal. All right, so since there's really no metals here, because again, everything to the left of that stair step is metals, we have to look and say, do we have a polyatomic that acts like a metal here? The answer is yes. So what you want to do is identify who the metal is. Okay, so we find out, oh, okay, the NH4 is the metal. Whatever's left is the non-metal. So what we have here is 2 polyatomics together, and it's really ugly if you're not really sure what you're doing here. So the NH4 is ammonium, the C2H3O2 is acetate, so it's ammonium acetate. Again, identify the metal, so like here, the aluminum, and that's pretty clear because we have the parentheses that really identifies who the polyatomic is. So the aluminum hydroxide. Here, the parentheses have done that for us too. However, with this one, it's a +1, -1, so you're not going to see any parentheses. So here we have ammonium carbonate. Here we have sodium hydroxide. We're going to skip number 6 because it's one of those exceptional ones. We're going to skip number 7, and we're going to go to number 8. Because again, I'm only focusing on our 10 polyatomics. And these are not your 10 polyatomics. These are oxalate, but you don't need to worry about that. All right, so looking at this one, we have zinc nitrate. Jumping down here, again, skip number 9. Skip number 9, magnesium phosphate. And then the last one is silver nitrate. And again, when doing these types of problems, probably the best thing you can do is learn your 10 polyatomics. If you can remember your 10 polyatomics, I guarantee you that this is going to be an easy thing. How, you say? How can I remember my 10 polyatomics? Make flashcards. What I highly recommend is making a flashcard. On one side, if you need to, is write the word acetate on one side of the flashcard. On the other, put the symbols. In other words, C2H3O2 with a -1 charge. Okay? So, here are your flashcards. I would make those and carry them around with you. Whenever you have some free time, whip them out and start looking at them and memorize them. You want to know these 10 polyatomics.